In section 14.3, we have learnt that when a narrow light beam travels from a medium to air, it bends away from the normal. However, if we look at the above figure carefully, we can see that there is no refracted ray observed when a narrow light beam strikes the glass air boundary. Do you know why? Let us investigate this in the experiment below.
In this experiment, you will observe the occurrence of total internal reflection. Put a semicircular glass block on a full circle protractor. Make sure the straight edge of the semicircular glass block is aligned to the 90-degree line of the protractor. Note that the middle of the straight edge of the semicircular glass block should be positioned at the center of protractor. Turn off the light in the laboratory and then switch on the ray box. Direct a narrow light beam towards the center of the semicircular glass block through its curved edge. Adjust the position of ray box until the angle of incidence equals to 20 degrees. We can see that reflection and refraction of light occurs at the same time. Record the angle of refraction. Increase the angle of incidence by 10 degrees each time until it reaches 60 degrees. Record the angle of refraction and the angle of reflection for each angle of incidence. We can observe that the angle of reflection and the angle of refraction increase when the angle of incidence increases. Moreover, when the angle of incidence exceeds a certain value, no refracted ray can be observed. All the light is reflected at the glass air boundary. To find out the minimum angle of incidence at which no refracted ray can be observed, direct a narrow beam of light towards the center of the semicircular block. Slowly increase the angle of incidence until all the light is just reflected back in the glass at the glass air boundary and no light is refracted. Record the angle of incidence. This is called the critical angle. When a light ray travels from glass to air with an angle of incidence larger than the critical angle, total internal reflection occurs. Now direct a light beam to the center of the protractor from the straight edge of the semicircular glass block instead. Increase the angle of incidence from 0 degree to 90 degree. A refracted ray can be observed throughout the process. When light travels from air to glass, total internal reflection will not occur at any angle of incidence.
In experiment 14.6, we can see that when a light beam travels from glass to air with increasing angle of incidence, the refracted ray and the reflected ray change. Let us study the three cases below. If the angle of incidence is smaller than a certain angle, both the reflected ray and refracted ray can be observed. The refracted ray bends away from the normal. If the angle of incidence is increased to a certain angle, the angle of refraction becomes 90 degrees, and the refracted ray travels along the straight edge of the glass block. If the angle of incidence is further increased, no refracted ray can be observed. All the light is reflected at the glass air boundary. This phenomenon is called total internal reflection. Total internal reflection occurs only when light travels from a medium, such as glass and water, to air with an angle of incidence greater than a certain angle, which is called the critical angle. The higher the refractive index of the medium, the smaller the critical angle is. Total internal reflection is more likely to occur